Okay. Moving on in Chapter 8, we are going to talk about solution formation. Okay. Now, when we look at an ionic compound, right? So, NaCl, sodium chloride, just for example. That is an ionic compound. I think we can all agree ionic compounds, of course, if you will remember back to Chapter 3, ionic compounds generally are between a metal and a nonmetal, or contain a polyatomic ion, or contain a polyatomic ion, I should say. If we put NaCl in water, it breaks apart into Na plus and Cl minus. Now, a couple things that I'll point out with this. First of all, we get two separate particles from this dissolution. Now, the other thing about this, we have these charged species that are now floating around in this solution. What does that mean for us? That means that if we were to try and use this solution to conduct electricity, this solution would be conductive. For that reason, we call this an electrolyte. Ionic compounds are electrolytes. Ionic compounds are electrolytes. Now, if we look at something like sucrose, all right, let's go with glucose, right? C6H12O6, if we dissolve this in water, it still fully dissolves in water. We break apart the crystal structure of it, okay? But these C6H12O6 molecules remain C6H12O6. Okay? So this is a non-electrolyte. All right. Now, to expand on electrolytes a little bit more, I'll scoot this up. To expand on electrolytes a little bit more, substances like sodium chloride, all the sodium chlorides that we put in water break apart into sodium and chloride, right? It is considered a strong electrolyte. Now, we will have substances that don't, where that's not necessarily the case. If we take acetic acid, just for example, CH3COOH, only some of it breaks apart, actually only a very small part of it breaks apart into our acetate ion and our H plus ion. By the way, bear that in mind, stick that in the back of your head, that's going to become a big deal in Chapter 9. But for cases where that happens, we call that a weak electrolyte.